Okay, so for 2324, we're really going to focus on the difference between what we call an observational study and an experiment. We're going to get more into experiments as we get into 24 and 25, but so today's kind of like a transition. But this is really like, can you explain the difference? So there was an article that I asked the class to read, and it's about, they look at a few things wrong with the article. We look at whether we can conclude that smoking during pregnancy will lead to ADHD. And based on the article, you say no. There are a few things wrong with the article. First of all, they look at just a small area in Missouri. That's where they base their observational study. And they only look at people who have twins ages 7 to 18. So part of that is, okay, you're looking at a small area in one state. You're only looking at twins. So that's like a lot of different things that you're looking at. And then they had to complete a questionnaire, which could lead to, some response bias. They might not want to say that they smoked during pregnancy and all that stuff. And then you may have heard this before. Correlation does not equal causation. You'll hear that a lot throughout this class. Because they completed a questionnaire, we can't really do a cause and effect because it's not an experiment. So there are two vocab words that you need to know. You don't necessarily need to read the article, but this kind of shows you just things that were already wrong with it. The response variable, what we're always looking at in a response variable, that's your variable of interest. So what are you looking at? Here we're looking at ADHD in children. So that's your response variable. What are you going to end up measuring or looking at? The explanatory variable is, what are you manipulating? So what are you going to be manipulating? In here, they're not really manipulating anything, but it's smoking during pregnancy. Okay, so think about like independent and dependent variables. It's kind of similar. So explanatory variable, what are you going to manipulate? Response variable comes after, what are you going to look at? So when it's impossible to tell if two or more factors is causing a change in the response variable, we say the factors are confounded. So studies like this one, like I said before, these are called observational studies. Because the researchers don't assign subjects to do one thing and subjects to do something else. In an observational study, you cannot conclude cause and effect because there is a presence of confounding variables. We don't know necessarily, like in that small area in Missouri, if there was something wrong, and maybe a lot of the kids have ADHD. We don't know if it's because of the fact that they were all twins. So because we're only looking at an observational study where we're not actually manipulating anything, we're not assigning any treatments, we cannot conclude cause and effect. That's where that correlation causation thing comes in. Is there a way we can show smoking causes ADHD? Yes, kind of. But there are variables in this scenario which makes it difficult. Right? Obviously, we can't tell women to smoke while they're pregnant. Like, that would be against all health, codes. So we can't do that. But technically, I guess, like in theory, you could, but obviously in the real world, we wouldn't. So if we're going to manipulate anything, if we're going to make impose treatments, that's called an experiment. And we'll really focus on experiments in 2.4. It investigates how a response variable behaves when the researcher manipulates one or more factors to determine if changes in those factors cause a change in the response variable. So a cause and effect relationship cannot be drawn from an observational study, as no active treatment is imposed on the subject. So this is very, very important to know. It's the major theme of 2.3, I guess. If humans are being experimented on, we call them test subjects. Other individuals, tomato plants, mice, whatever, those are usually just experimental units. The independent variables that the researcher manipulates in the experiment are called factors. So, there can be multiple factors in an experiment. Obviously, you might only want to manipulate one thing, but you can do two if you need to. So, besides the factors, for each factor, specific values that the experimenter chooses for a factor are called the levels of the factor. So if we were telling pregnant women to smoke, one level would be, one cigarette per day. A second level might be a pack a day. And then a third level, we talked about that placebo, you might have no smoking at all. Ooh, I don't want to go past a pack, I don't think. A combination of the specific levels from all the factors in the experimental units received are known as the treatments. So if there's only one factor, you only have the levels that you want for that one factor. If there's multiple factors, you may have more treatments than just these three. So let's suppose I wanted to test the effectiveness of temperature and humidity on computer performance. So the factors for this, we're looking at, what are we going to manipulate? We're going to manipulate the temperature and the humidity. So for temperature, for my levels, I want to kind of have a cold level, a room temperature level, and a hot level. So for maybe you have a cold level 40 degrees Fahrenheit. And then you have a room temperature, so 70 degrees Fahrenheit. And then you have a hot level, so 90 degrees Fahrenheit. For humidity, again, you want a medium, high, low. So you might have, I know this is probably not right, but 0% humidity. Then you might have 50% humidity. And then 85% humidity. Maybe not exactly 100%. So then the treatments would be all the different combinations. So we're going to end up with 9 treatment groups. So you can have each temperature, so 40 degrees Fahrenheit, 0% humidity, 40 degrees with 50% humidity, and then 90 degrees Fahrenheit with 85% humidity. And then we're going to keep going. So now I'm going to do, I have to make that 40. And then we're going to keep going. So we're going to do room temperature. So 70 degrees with 0%, 70 degrees, 50%, 70 degrees with 85%. And then we're going to do our last 3 would be with 90. So 90 degrees with 0%, 90 degrees with 50%, and 90 degrees with 85%. So there could be more than this. This is just a simulation. So a recent study declared that people who go to church have longer life expectancies than people who don't go to church. Do you think this was an observational study or an experiment? Did we impose any treatments? Probably not. So I would think it would be an observational study, because there's no treatments imposed. Assuming that there's an association between church attendance and longer lives, can we conclude that going to church is the cause? Again, no. In an observational study, we cannot conclude cause and effect. Okay, because we did not impose anybody on going to church. So an experimental design, just at the bottom here, we're going to do a very general form of the experimental design. Well, like I said, we'll get more into that with 2.4. But just in general, what an experimental design sort of looks like. Usually we randomly select subjects. So we're going to use all of our random selection techniques that we learned from 2.2. And then you randomly divide and impose treatments, making sure to incorporate levels and factors. And we'll get into specifically how do you randomly divide and all that stuff, like I said in 2.4. And then we're going to measure the response variable. And usually from that point we draw conclusions. If we're working on inferential statistics, or sometimes we just summarize the data. If it's an observational study, we might just summarize the data. If it's an actual experiment, we might draw conclusions. So we'll get into more like actual specifics, like I said, with 2.4, but this is just like your generic experimental design. But the big thing to take away from today is knowing what's the difference between an observational study and an experiment, and knowing that you can't have a cause and effect relationship with an observational study.